So let's see what we do have and how we solve this problem. And I'm going to actually share the screen and show you some code. Does that work?
Yep.
Yeah.
You see code?
Yeah.
Yes.
Okay, so this is the library I was talking to you about, and I went straight to prepare Escrow, which is a bit of a monster. See, it's a lot of lines, 56 lines. It really screws up our statistics on Python, but here's how we do it, and it's not that complex. So the first thing we do is we create an escrow, and this escrow, okay, I forgot about that, I forgot to mention it, but another huge difference between Stellar and everyone else is that for pretty much anyone else, you only need to have a key pair, and this key pair can be used as an account. In Stellar, you actually have to create an account. An account does not exist until someone who has an account creates an account. And not just creates it, but actually funds it. You need to have the native coin of Stellar, XLM, inside your account. And this is hard. When you use testnet, you have services that you don't even need faucets. You have very, very easy, very practical services to get an account up and running. If any of you work with start working with Stellar, I highly recommend the Stellar Laboratory, which has a nice web interface that lets you do pretty much anything you want to do with Stellar, and read all the transactions and decode them, and it's really useful. But it's still, once you go out of testnet, that means that every new client that we have, we need to somehow fund this account with XLM, which is a coin that actually has value that we need to purchase. It means we need to have this funding wallet and a whole mechanism which is completely centralized of funding, of just being able to buy an account. And again, like I said, it's not as free and trustless as Bitcoin. That's one of the things really shown. So when you prepare an escrow, what you do is use some of your own XLM to create an account. And you create an account and you set it up to work with our coin, with a pool. And then you make up a bunch of transactions. Now, since I, as the launcher, created this account, I have full control over it. And the first thing I need to do is to receive that control. So this is here. This is the huge operation that you see here. It's a transaction with a bunch of operations. And as you see, it's last because it actually requires us to already know what are the paths that we want the payment and the collateral to flow in. So there's a refund transaction, which is time locked. That's very easy. It's just like Bitcoin. We create this transaction and we give it. You notice there's a sequence. Every transaction in an account has a sequence, and this already has a sequence delta of 1. It will be, if the current sequence is n, this will be n plus 1, and of course you only can increment it. And then there's the payment transaction, which has the same sequence. So only one of them can actually happen. And this one isn't time locked. You will see how it is locked later on, because of course it needs to be used only after the recipient signs it. And let's wait with this for a second. And then basically what I do is I create this big transaction with a bunch of operations that says that the payment is a pre-authorized transaction, and it has a weight. It means that any transaction that matches this hash, which of course is only one transaction, any transaction that matches this hash has a weight of 2. And then he goes with the payment, or this was the refund, right? And the payment has a weight of 1. That means, and eventually right over here, you can see that we set up the different weights. We set up the weight of the master key, which is 0, we want to disable it. And then we have 3 thresholds. The low threshold and the high threshold are hardly interesting. They are meant for, the high threshold is for serious operations about setting up thresholds, for example. The low threshold is really for meaningless operations. The medium threshold is for everything that's really important. It's moving value around. So you can immediately see that the refund, which is time locked, has a weight of 2. Once the deadline passes, this has enough weight to be authorized. And whoever has this can just publish it. The fee will be taken from the escrow account itself back to the launcher. Right? This is our refund. Also the collateral, which we enter into in a minute. However, the payment transaction has a weight of 1. And we have someone else who has a weight of 1, but this is the public key of the recipient. So as soon as the recipient signs this transaction, it can be used along with the weight of the pre-authorization to get to the value of 2, which means that this is a valid transaction and payment can be done. And again, this is payment along with returning the collateral. And then we have the merge transaction. This whole thing leaves one serious void because I've created an escrow account, I've funded it with XLM, I've locked it and did all the pre-authorized transactions, and then of course I'm going to put my payment in it, and the courier is going to put his collateral in it, and if, on the case of a successful delivery, he's going to get his collateral and the payment. In case the deadline passes and there's no successful delivery, I'm going to get the refund and the insurance. But once that is done, we still have this dead account. And it still has XLM, it still has Stellar's native coin in it. And we need to be able to reclaim. Now, it's not a lot of money. The value of XLM changes annually, but really, we're talking about something between $0.50 and $3. But we still want to get that back. It depends on how complex the account is. I mean, every one of these makes it a bit more costly. But once we're done with it, we have the merge operation, which kills the account, destroys it, and sort of merges it into mine and gets back all the XLM back into my pocket. Now, very important, if you ever get to work with Stellar and you need to use this trick, the merge is only possible when the wallet has nothing except for XLM. It can't have credit in any other token, and it can't even have trust in other token. It can't allow the sending of this token. It needs to say, I'm now a strictly XLM account, I only have XLM, and then you can merge it. So that's basically our escrow transaction, but maybe, I totally missed that. But of course, the merge transaction has a higher sequence delta because it needs to happen after either the payment or the refund. And the original set options has no sequence delta. It works on the current sequence. So eventually, when you get these transactions back, the sequences on them are the set options is going to be the current one, the payment and the refund are going to be n+1, and the merge is going to be n+2. And if you happen to mix up the order, then your coins are gone. And in this, it's very much like Bitcoin, like the crypto we know and love. If you mess up, no one can refund you. Okay, before we move to the even more complex one, let's see if you have any questions about this. Was it even clear? I don't know. I'm swimming in this for so long. Maybe Oren remembers some things I missed.
Is this clear? Do you want to get to the deeper one, or stay this level? Maybe explain stuff about Stellar, or go to the next iteration. Stefan, what you say?
No, it's fine.
Thank you very much for this. Can you just explain us how do you handle time, tracking time?
The question is, how do you handle time in this?
So again, because Stellar is so practical and so built with these kind of operations in mind, it's pretty trivial. I'll show it to you here. Where's the refund?
He's using Vim. Anyone here uses Vim? Wow, several are using Vim around here.
Highly intelligent and competent people.
I still think you're all crazy.
Yes.
So here, this is the way. Oh wait, this is even the right one. This is the right one. This is how you handle it in Python with PyStellar, which is the official Python library to work with Stellar and Horizon.
But by the way, how many people here
By the way, we contribute to a bit. You have this function. It's called add time bounds, and you can say I did something clever here with this. If any of you are familiar with Python, so I needed to get this thing that returns actually, like, it needs to be an object. It can't be just a dict. So this is how you work with add time bounds. By the way, there is in the works. There's a version of Stellar that handles this even better. So you don't have to do the little dirty Python trick I include here. And you can always add memos for everything. This is fun. You can add short memos to your transactions, which appear in the blockchain. They're limited in size, but they really help you out when you go to explore the blockchain and you try to figure out who paid what and how it worked. This is rather helpful.
Yeah, Sal, maybe later you can show our Web Explorer and then zoom into a transaction and maybe show the memo.
Oh, sure. Yeah, we can do that now.
Yeah. So Israel is going to show you like a quick and dirty explorer that we did just to see the packages. By the way, there are more than 100 packages that that we did a proof of concept last month to deliver. Yamit, our COO, is just working behind, made sure that 100 packages arrive. We used local courier, we used trains, we used bicycles to deliver them. And we put on Israel, make a quick explorer that you can see the packages. Can you put it on the screen? So if you go to PAKET.global is our website. If you go to explorer.paket.global, that's our website. You can see a map with heat map for demand, supply, and stuff like that. You can do. It's very raw right now. And this is actual packages happening. This is a demo package that we did. Israel click that, and you can see we sent my business card that I forgot in Israel, and it went from Israel to Serbia. But if you click. But if you look at, maybe take another one or whatever that you can show the actual transactions for. If you look at the link here under delivery details, this long hash is the public key of the escrow account. So each package is represented by the escrow account that handling all the different tools. So if you click on it, I don't know if you want to do it now, you can see some of it, but if you click on it, you go to the regular Stellar Explorer. It can be any Explorer, and they take it from here.
Yeah, and here are the thresholds. Remember, you saw them 1, 2, and 3. These are the 2 pre-authorized transactions.
We don't see your mouse, so if you can highlight, maybe we can see what.
Oh, okay. So, thresholds.
Yeah.
And these are the pre-authorized transactions. You see one of them has a weight of 2, one of them has a weight of 3. And This is the public key of the recipient, which has a weight of 1. And this is the public key of the original creator, which has a weight of 0, because as soon as we make it an escrow, we want to disable it. I don't want to be able to touch it. I need to be able to prove that no one can touch it.
That's what makes sure the packet.
That's a big part of the deal. That once you go around, you can, of course, we have this nice mobile application that will check this for you and show you that everything is on the up and up. But you don't need to trust anyone. You can just look at the distributed ledger. You can look at the so-called blockchain, and you can see that this key no longer has control. That all the money inside, and we hear the actual transactions happen.
Hold on for a second, Sal. The fact that the issuer gets a weight of 0, that's exactly the part that means that the packet project, that I cannot block any transaction. So if there's a transaction between you guys, of course, the packet is not part of it. Or, by the way, any application that creates this can do the same. So actually, if you want to make sure, well, your application, of course, make sure of that, but the application can make sure that no one else can control the application, and you're really going to get the funds, whoever signs that's receiving the package. Sorry, go ahead, Escrow.
Yeah, so here are all the transactions and the different operations that went through. You can see a lot of set options, right? Because we had all these pre-authorized transactions. You see a trust change when we trust bull to the exact amount of the payment plus collateral to avoid the problem I described earlier. Right? If I go here, wow, it's fun. Yeah, so here is, you see that there's a lot of numbers. Back to this. Oh, we had here the list of operations in Escrow, but we go back to the code. Any other questions about the escrow, or do I move on to the relay?
I actually have a question about the Explorer thing more. If you go, can you hear me now, or?
I can hear you, and I can hear you weakly, but Oren will...
okay, so not that one, but your Explorer. I saw the train thing, and it has a cost. Is it the cost of the train? And if it is, does the courier pay the price of the vehicle, or... So for example, 5 location changed.
Yeah.
I'm so happy you guys are actually looking at this. Wow, this is heartwarming. Yeah. So it's a good question. Where you see the leg price and the cost here are all things that are in our keyword ARGs, which are things that aren't essential to the system, but are just statistics that we're trying to hold. And in our proof of concept, we wanted to add the cost, not in bulls, not in SLM, but in actually local currency, how much it cost the courier. So we can have our own statistics. So basically, if a guy takes a cab, when he passes the package on, he first says, this leg has cost me this and that, and our server makes note of it. So this is what you're seeing here. You see a taxi that cost 20 shekels, a train that cost 8, a plane that cost 200, and a taxi that cost 10. Of course, all of these are estimates, just named by the guy because this is a demo package.
But on the real packages,
that's what it is. This is just the way the courier currently works for us, and it usually is us, just reports back and says how much this cost him in local currency, so we can keep track of our own costs.
Okay, cool.
So I think we have like 15 minutes, so if you want to go to the relay maybe.
Oh, absolutely. So let's do that. Okay. Now, the relay works similarly, but not quite. The first thing you need to understand about the relay is that let's for a minute imagine a world without relay, with only the original escrow. In here, the payment is done to a specific person, to the courier. He has an address, he has a key pair, and he has a pre-authorized transaction that moves the bulls to him if the recipient signs. In a world with relays, the courier will never give his own address. Will never say, here, pay this money to me. Because this lack of smart contracts, the solution we have is that the courier, when he wants to accept the money, always creates a special account just for that. And again, that's not an easy decision because it's not a very costly operation, but it does cost money. Money that you get back eventually, but you need to put some XLM and fund this new account. However, it is worthwhile because once you do that, you have your own main account, and you have the special, this is probably what you have on your wallet, the thing that you actually see money coming in and that you use it from. And then you have a special account that you opened just for this new delivery. This is the one that's going to get the payment. And if at any point you want a relay, you're going to change that account into a type of escrow account. Actually, it's not an escrow account, that's terrible, I can't say that. It's a relay account. And the reason they're so different is that an escrow account holds the money. It actually holds the coin, it has a balance. The relay account doesn't have a balance, it is out of everyone's control, it has pre-authorized transactions that can flow only in one of two ways. But it doesn't have any funds, it just exists there until payment is done. Once payment is done, the payment moves to this account, and from this account it can only go to it can only go to a certain person. And you can have as many of those as you want. Of course, the other option would be to have a real escrow account, but that escrow account would mean that there would be more money stuck in the pipes. It means that there's an escrow with a payment, and then another escrow that contains a part of this payment. Let's say if it's half, if it was 10 bulls, and now we're dividing them 5 and 5, then there's one that has 10 bulls, and then there's another escrow that has 5 bulls. Together that's 15, and that's hardly optimal. So we have this relay, which really isn't. By the way, in Solidity, it did sort of work the same way. It was very much more similar to the escrow, because you could move the funds from one escrow to another. Solidity lets you do that. In Stellar, this is impossible. Okay, I don't know. I think it's impossible. I'm pretty sure it's impossible. I've tried a lot. So you have this special account that you created for the delivery, and now you want to turn it into a relay. So the first thing you do is you create this relay transaction. So splitting the payment between the relayer and the relayee. And of course, this transaction is invalid unless money is placed in that account. So that's really simple. And then you have, again, a merge transaction. Never forget to merge, because you're going to lose XLM that way. And you see this has a sequence delta of +2. And it basically removes trust. I told you have to get rid of all your tokens. You have to make sure you don't have tokens. You don't have the option to receive tokens. But here in this case, this isn't enough. We actually need another merge transaction, because let's say that the deadline is passed, no money was moved into this account, the relay account is empty, and the relay transaction, this one, was never submitted because there's no reason to submit it. The delivery failed. In that case, you can't have the merge transaction. And anyone can immediately see why? Give you a hint.
Because the delta doesn't match. I mean, there's not the one transaction before.
The sequence is too high. The sequence is +2. If you will not submit this one, which is a sequence of +1, you will not be able to submit this one, which is a sequence of n+2. And you say, okay, so maybe I'll just send some stupid null transaction to bump the sequence. There's actually an operation called bump sequence, which is used usually to invalidate transactions. But I can't, because I no longer have control of the relay. And this is this step, the set options, which gives pre-authorized transactions and eventually freezes everything by giving the master key a weight of 0. So nothing can happen with that account except for these three transactions. And one of the transactions is the relay transaction. We hope this will happen. If this will happen, we can always submit the merge transaction. But we need a second merge transaction, this one, which is a sequence delta of 1, but has a time lock. So you can be certain that it will never pull the rug under the feet of the courier. So only in case the deadline is passed and the relay transaction, which depends on the payment transaction, wasn't submitted, you can still do the merge transaction and close the special account that you created. It's going to be shy a few fractions of an XLM, because really, this is something that I think Owen said quickly about Stellar. It's fast. It's so fast that you can treat it synchronously. You don't need to wait on average 10 minutes for a block to pass. It's an HTTP request, and it comes back, and things have already happened. They've already been signed. They've already been notarized, and are already in the blockchain for everyone to see. And fees are very, very cheap. And like I said, no one's making money out of the fees. They're just an anti-spam mechanism, and they also cause this slow inflation. In any event, the fees are really minimal. You are going to lose a few fractions of an XLM here, but you're going to get most of it back. And then, of course, I set these transactions as the only signers. In this case, there's no signature of a public key of the recipient. I don't need the recipient. And in this case, all the thresholds you can see here are set to 1. And also here, all the weights are set to 1. Because anyone who has these can submit them as long as the conditions in the world, in the ledger, are okay. The conditions being, again, for the relay, we need money to be in the account, which means we need the payment to happen. For the merge, I call it a sequence merge envelope. For the merge envelope in case of success, we need one. Everything that needs to happen is that this one will be submitted and the sequence will be bumped. If the sequence is bumped, you can submit this, anyone can. Of course, it will always merge it to the same account. And the last one is for the time lock merge envelope. And again, if the deadline is passed, then you can merge. Nothing, you don't need any signatures, nothing stops you. And that's where our code becomes sane again, and you see we enable the too many arguments, and things become sane. This is really the hard part of our code, the way we actually use Stellar and the cryptography scheme of Stellar to achieve what is a very simple smart contract. Any questions about this?
Yeah, I do have a question. So, if you go back down to the relay code, what stops me from submitting? So, can you go down? I don't know if you can hear me actually. Okay.
Yeah, I can hear you.
Okay, so in the relay transactions where you have the second case where a relay didn't happen, so the sequence is 1. What stops me from doing first the time lock merge and then doing doing the transaction where there's the time lock and then doing the sequence merge envelope? I mean, will it just fail because there's no funds, or is it because they're not part of the same envelope?
I'm not sure which one you're talking about. There's the relay, and there are 2 merges. So the relay, the only thing that's stopping you from submitting it is the fact that there is no money in the account. That means, by the way, that if someone else sends money into the account, just out of his own goodwill, you can immediately use the relay. And this isn't a problem, because the person is going to get paid. There's going to be more money for everyone. That's the only thing that stops the relay from happening. The fact that there's no money there yet.
Okay.
The only thing that stops the sequence merge envelope from happening is the fact that the sequence is too low. That no transactions have happened. And the only transaction the only two transactions that can happen with the previous sequence, with n+1, are the relay and the time locked merge. And the only thing that stops the time locked merge from happening is the time.
Israel, the sequence is a bit different. You want to say a few words about how the sequence works?
It's different from I don't know, it's very much like okay, if you happen to work with some cryptographic web APIs, there's usually an always incrementing nonce to avoid replay attacks. You guys know about that?
Yeah.
So it's very much very similar. Originally, as far as I know, it was inserted for similar reasons, but basically what it does is it makes sure that if you have two pre-authorized transactions, only one of them, and if they have the same sequence number, only one of them can happen. If you have something that has a higher sequence, then it will always wait for something in the lower sequence to happen. And like I said, there is a special operation that's called bump sequence, which is specifically used to invalidate such pre-authorized transactions. You have a pre-authorized transaction with a sequence, it can be submitted under some conditions, but if you bump the sequence, it becomes invalid because its sequence is too low now. And the sequence has to be sequential. So you're not just always incrementing, it's always +1. And again, in the Stellar laboratory, when you compose transactions, that's nice. I'll maybe show you this quickly because it is because it's really useful if you get to use it. So here's the account creator. You generate a key pair, and then you can fund it here. And there is an endpoint that lets you check everything. And there's a transaction builder. And in the transaction builder, you see you have your transaction sequence. Once you input a key here, let's actually use the one that we can't do that. Once you input something here, you can query the blockchain and get the current sequence right here. And the base fee is optional, it gets computed. Almost everything here is optional. You just add operations of whatever type you want. And eventually, once it's done, you can also enter a seed and sign it and submit it. And it's very convenient. Anything else about this, about Stellar, about the relay? The relay.
Okay, we getting to our 16-minute limit. If there are any questions, yes, one more question.
Can be more business-wise, not so technical question. How do you determine collateral?
How we determine collateral? That's a great question. The way to determine collateral, we use the best way to determine collateral. We let the people decide. So if you have, if I want to send this laptop somewhere, I can decide if I want someone to pay me $2,000 because if I lose it, that's what it costs, or $10,000 because my private keys are inside. And the courier on his end can basically say, well, no, I'm not taking it. On the other hand, another
I'm taking it only if you pay me more.
Exactly. So we agreed to on 100 tokens, give me 200 tokens because now I have to secure it. Maybe buy a gun to kill anyone who tried to take it, or whatever. And you laugh, but if you think about it, that's one of the keys here because if you, an example I use is people around Israel, Antwerpen, and New York that dealing with diamonds. I don't know nothing about them, but I'm sure that they know how to take like small stuff and secure it when they take it around. Now, they are willing to, in other words, they're willing to transfer for a nice fee something in a very small for a very high collateral, right? So if I have a discount key that I want to send to Antwerpen, now I already have a system that knows how to do that. And that's really, when you start to think in a decentralized way, that's where we start to get the extra value from all kind of people that you don't even think about that suddenly can do all these great things for you because one can take very expensive stuff, one can travel all the time to Africa because it's an NGO and he can find exactly the tents that you want to send your whatever to, etc., etc.
refrigerated deliveries.
Yeah, we can. Yeah.
And does because we've seen you are tracking the local costs, or let's say the level of local economy and the expenses. Is that have any effect on the proposed initial price or not?
Yeah, of course. So we get this, we gather all this information, and of course we're making it public so anyone can see it. So now the information is not siloed, you know, at FedEx computers. Everybody can see and share it. And the second layer of the routing can actually use this information to suggest to you what's going on. So if I want to send a package to Belgrade, it will tell you, look, it looks like if you pay $17, it will get there next week. But if you pay $54, maybe it will get there in 2 days. So maybe you can find the route. So all this information, the aim is to put it again to do everything public, so everybody can use it, of course.
Thanks.
Okay, so thank you for the chance to visit the MVP workshop, and we're in discussion with the MVP workshop to maybe work together. So maybe we'll all meet each other soon on real life projects. Thank you.